Right. Good morning, eighth grade science class, both in person and online. Today, we're going to be going over day 8 of our 10-day STAR review. We'll have 2 more days next week for this, but we're going to be going over just the questions and the matching at the very back. So starting off with number 1, this section is going to be about Earth and space. So a little bit still about your Earth cycle, your Earth systems. Think about like plate tectonics, weather, things like our water cycle and things like that, okay? So number 1, which of the following landscape is most likely located far away from a tectonic plate boundary? Well, we know that our tectonic plate boundaries are either convergent, meaning they come together, divergent, meaning they move away from each other, or transform, meaning they move side by side. And our plates sit above, all right, molten magma. And that magma, all right, that hot magma, that convection current down there causes those plates to move. And that's why we have our continents moving away from each other, went from that original Pangea, all right, to the continents that we know today. But whenever these continents collide or move away from each other or slide side by side, we get land features. We get natural features on the surface. And we can see here we got mountains caused by when plates are colliding together and forcing that rock up. It's kind of hard to see what this is right here, but it looks like some type of hillside, maybe like a curved mountain range almost. So if this is any type of mountain range or kind of a hilly area, so that could be a sign of our also convergent boundaries. Here we have a volcano, right? A volcano is caused by subduction. That's when one plate gets sucked under the ground, and then that magma has to come out of somewhere, so that pressure is released in the form of a volcano and form that magma and lava, okay? But number D, it looks like it's just a railroad strip on a pretty flat piece of land. So if you can't see that really flat, you can also see that they're building a rail line here. And so if someone's going to invest in building a rail line here, they're probably not going to want to build it in an area that is prone to movement, a lot of movement like earthquakes or volcanoes. Even building trained up in the mountains is very difficult, but this looks pretty flat. So you can guess that this is the only area that's going to have no tectonic activity. So this is only one that's not located by a boundary. All right, answer choice B. Number 2, it says Miguel's school often practices evacuations in the event of a tsunami, a large ocean wave created by an underwater earthquake. So I love this question, guys, because it literally tells you the definition of a tsunami. So if you came across another question on the test that asked you about a tsunami, well, you could always just go back and read the definition of it. So I always say don't stop, all right, on a question, move ahead. You can always go back and answer it later, and things might answer them for you, okay? But Miguel School is probably located where, all right? Near a tornado alley. Well, tsunamis aren't caused by tornadoes, okay? So we can knock off the tornadoes. And a marshy region. A marshy region is an area that's prone to flooding. It's usually very wet. Think of swamps, things like the marshes in Florida and things like that. That's going to be near an aquatic area. So I'm not saying that's wrong, but we can do past it and make sure there's not a better answer choice. Near a place often hit by hurricanes. Hurricanes don't cause tsunamis, but this area maybe that's prone to hurricanes would be near a shore. So it could be a reasonable choice, but let's keep going down. Near a plate boundary. So tsunamis, guys, tsunamis are caused by earthquakes under the water, and it causes that change in movement of the water rapidly, and it causes a large wave to form. That wave will get bigger and bigger. So those earthquakes offshore is caused by plate boundaries, all right? It's gonna be a transformed boundary, but it's gonna cause your tsunami. A, B, and C, none of these are talking about plate tectonics at all, okay? Number 3, if you looked at a map of Earth from 100 million years ago, it will look much different than today. That is because, so what is the reason that our Earth looks much different than it does today? Let's go through our answer choices. The constant circulation of magma underneath Earth's crust has caused a crustal region to move. Well, we know there is a constant circulation of magma, and we do know that our crustal regions do move. So let's keep going, make sure there's not a better answer choice. Life forms and organisms living on Earth in the last 100 million have caused landscape to radically change. Well, we do, right? Humans have changed the landscape quite a bit, but not radically. And all the other organisms, they're not changing the landscape, all right, like we are. So no, B is not going to be a good choice because we're not really radically changing. We change it pretty slowly, those of us that do. And then C, erosion and weathering has changed the shape and location of the continents. Now, erosion and weathering are a thing, but they're not strong enough to change the entire shape all right, and location of continents. So shape, maybe, but location, no. Weather and erosion can't move continents, all right? And then gravitational forces from the moon and sun. Now, you know that this is ocean tides. Okay? This is your ocean tides. This has nothing to do with your continents, all right? The sun and the moon's gravity affects your ocean tides, okay? So our only good answer choice, guys, is A. We know that A is true. We know it's the best choice now. Number 4, some part of the Himalayas are growing at a much higher rate, as much as 1 centimeter a year. What is causing this vertical growth? All right, so we have the Himalayas growing rapidly. Okay, so remember, subduction zone is when one plate is getting sucked under the plate, right? The less dense plate is getting sucked below the denser plate. And then B, huge underground geysers create pressure to push the mountains higher. That'd be really cool. Sounds like something in a movie, but no, those geysers aren't going to be strong enough to push mountains, even if they're water geysers underneath the mountains. Sediments from eroded materials are being deposited. How would those sediments be deposited on the top of the mountain? That's going to be really hard to do. So no, it's going to be hard for sediments to get on top of a mountain. So we know that's a bogus answer choice. But two continental plates colliding, that is our convergent boundary, and we know that convergent boundaries cause mountains to form. So D is our answer choice here. Okay. You could always look back over here and say, "Oh, look, we have mountains. That was a boundary. That was a plate boundary." So we know that's going to be one of them. All right, moving on. We're going to use the satellite image below of the lower Mississippi River to answer the questions on this page. This picture is a little hard to see, so let's see if I can pull a colored one for you. But as you can see here, we have the Mississippi River. Okay. And it looks like Mississippi is going to continue down here. Okay. And that's where it's marking for us. And we have A and B. Right. So it says the Mississippi River flows from the northern U.S. to the Gulf of Mexico and picks up a tremendous amount of sediments. What process is occurring at point A? All right, so let's look back at here. It's saying that there's a tremendous amount of sediments, and sediments come from the process of beating down rock, dirt being washed away. And that sediment is just kind of like sand, kind of like dirt, clay, things like that. But that sediment is caused by erosion. So there's erosion that's happening up here, all right, all the way through this river, and then dumping off, all right, throughout the Mississippi River until you get to the Gulf of Mexico, all right? So at point A, we most likely are having erosion taking place. It's not depositing. Precipitation is rain. It's definitely not precipitation. Solidification is when something becomes solid. So really, guys, your only two answer choices there are erosion and deposition. It says that it's picking up sediments, not depositing, all right? It has to have something to deposit, right? So it starts to erode. It starts to erode the rock, the land, and it pushes it down with water. Moving on to number 6. All right, so for number 6, guys, it says the U.S. Army Corps of Engineers is concerned that the Mississippi River may jump its bank near point A, meaning it's going to, let me finish kind of drawing out this river a little bit for you guys. So the Army Corps of Engineers is scared that the river is going to jump its bank, all right, at point A, meaning it's going to form a new river, all right? If a big flood took place, it would form a new channel, all right, further west, all right? If this were to occur, what would happen to the current river delta at point B over time, okay? So we're saying that the river is going to possibly break off and form its own channel right here. So you're going to have less water flowing down, all right, the Mississippi River, and getting to our delta at point B, all right? So what's going to happen to point B over a period of time? The delta would begin to shrink. Well, sure, if less water is getting there, you're getting less sediment, You're getting less sand, less silt, so you're going to start to shrink over time. The delta will become much larger. It's not going to get larger if it's getting less material to it. The size of the delta will remain the same. Couldn't possibly serve, but that delta is constantly getting washed away by the ocean. So it's going to need to constantly be built up over time. So it's probably not going to remain the same. Or the delta would have a higher amount of sand and silt. Well, if there's less water moving down the Mississippi River on this particular location, you're not going to have much sand and silt located at B. So you're probably going to have much less, not higher amounts. So our only answer choice is A. All right. And then on this map, what is happening at point A? We already said that, point B. We already said that point A is erosion. We have the water taking everything down. And then eventually that water enters the ocean, and that sediment, that sand, that silt is left. So what is that process called? It's called depositing, all right? So position, to deposit that stuff on the ground, okay? Like you go to a bank and you deposit your money, all right? This river is depositing all its sand and silt right there on the banks. Perfect. Thank you, sir. Just like I fix it. Yeah, you're good. Thank you, sir. All right, good. So, position. Nothing solidifying, not being taken away, and it's not raining. So, deposit. Good. Number 8. Which of the following discoveries does not necessarily support the theory of plate tectonics? All right. So you remember, you got to know your theory of plate tectonics. All right, this was the theory that Alfred Wegener had, that the continents at one point in time were all connected, all right? Call it Pangea, supercontinent. And over time, all right, those continents broke away, and moved across the ocean, separated from one another, okay? This is called plate tectonics. And his idea was founded by some clues that he had. He noticed that plant life and animal life was similar on the same continents, but clearly they couldn't have swam across those oceans, and he didn't believe that a land bridge was really the answer for that. So he thought that maybe at one point in time these lands were connected when these dinosaurs or these animals or these plant life were alive, and then they died, became fossils, and those fossils were separated over time. How did they get separated? He also looked at weather patterns in certain continents by studying the Earth and looking at the history of those areas, and you see what the weather was like in those areas, see if any of those things line up. But let's go through our answer choices here. Which of the following discoveries does not? Make sure you understand that we're looking for what does not necessarily support it. Fossils of the same species were discovered in Scotland and Appalachian. So again, fossils were the same. Early sonar used in World War II found mid-ocean ridges. They did start seeing things underwater, which furthered the idea of plate tectonics. Alfred Wegener wasn't fortunate enough to have this information, so he wasn't able to really prove his idea. But yes, eventually they were able to start mapping the bottom of the ocean. We started seeing the features that were down there, including mid-ocean ridges, seafloor spreading, and so forth. The shape of the Western Africa is similar to the eastern coastline of South America. They fit together like puzzle pieces. And then many different species of dinosaurs were found in the Western United States, right? So yes, we have found a lot of dinosaurs in the Western United States, but what does that have to do with any other continent? We're just talking about the United States. So it's not talking about plate tectonics. Yes, it is true, but it's not talking about plate tectonics. Mid-ocean ridges, all right, and finding them using sonar, all right? Same species discovered in different parts of the world, okay? And then the shape kind of put together like a puzzle piece. All those are choices except for D. Okay. Using the chart below, what source of energy best fits X and Y? Okay, so we're going to talk about our different types of energy here. Okay, so we have atmosphere. All right, our atmosphere, all right, is a gas. Okay, and what is our primary source of convection current? Remember, convection, all right, is just cold goes down, hot goes up. Causes a circular motion, guys. Think about hot air balloons, hot air rises, okay? Cold air drops, all right? So cold air drops, hot air rises. This causes convection current. So what's causing our atmosphere to heat up or cool down. All right. So let's kind of go through some of our answers here because we can start marking off X. All right. So, well, we know that our sun, all right, is the only thing that can really get to our atmosphere, right? So our sun is heating up our atmosphere as well. This is known as solar energy. Let's look at oceans. The ocean state of matter is a liquid, right? It's mostly made, it's water, right? But our primary source of convection, what heats our ocean up and cools our ocean down? All right. Well, we know our Earth is heated up with our sun, so is our oceans. Think about how big our oceans are and how much solar radiation those oceans can soak up. Okay. So we got to find an answer choice that answers both X and Y as solar energy, and we're looking at A. All right, number 10. Number 10 says that every year in late spring, the NOAA issues a forecast on the number of hurricanes. Now, remember, hurricanes are caused by warm ocean water, all right? If you have cold ocean water, you're not going to have a hurricane. But if the ocean heats up, you're going to have a hurricane. So make sure you go through the answer choices, and you're going to find anything that talks about water temperature right here. Remember, guys, don't need to know the answer, but you know it has nothing to do with air pressure, evaporation, or gravitational pull. So it has to be your water temperature. Number 11, in which country is the following weather map most likely to be seen? As we see, we got cold air being pushed up and warm air being pushed down, and we have our low pressure system, all right? Since we have warm air going to be dropping, all right, imagine your equator right here, where all that warm air and water is, that's going to be dropping. So we know that this country has to be beneath the equator, and we're also going to have cold air coming up from the left, all right? This could be our South Pole, right? So we got cold air coming up from our South Pole. We got warm air coming down from our equator. This has to be good old Australia, down under, for number 11. Okay. Go ahead and complete the vocabulary matching on the back, just 1 through 12. All right, I'll be posting just the key for this tomorrow. As always, hit that bell icon, like, and subscribe, and have a good day.